In a previous video, we talked about how polar coordinates could be useful for certain graphing applications rather than Cartesian coordinates. This video aims to show you a few of those examples. And the first example I'd like to show is a circle. So if I have a circle that's centered at the origin, so something like that, and I have a radius of, let's call it A, the equation of this circle in polar coordinates is simply r equals a, whatever that number is that's the radius. For example, a circle that has intercepts of 2, -2, and 2 and -2 would have the equation r equals 2, and that's all. Clearly that's much more simple than Cartesian coordinates. Now, it's also worth noting that here there's no theta anywhere in the equation, and that's because irrespective of what my angle is, the distance from the origin is 2. That's very similar to the way that if I had a vertical line on the Cartesian plane, the equation of that line would be x equals something and y won't appear in that equation because regardless of the y value, x always equals 2. Another application where polar coordinates might be quite handy is if we have a straight line going through the origin. For example, something like that. In the same way that theta doesn't appear in this equation, r won't appear in this equation because my angle from the positive x-axis to this line is always exactly the same. It never changes. So here, for example, we might have a line that has an equation theta equals pi over 3 or something like that. And for all values of r, theta only ever equals pi over 3. So for circles and straight lines that pass through the origin, polar coordinates can be a very easy way to show the equations. Things do get a little bit different when I have a straight line. So for example, if I had an equation in the Cartesian form of ax plus by equals a constant, let's call it d, then I need to make some substitutions for x and y to get it into polar coordinates or the other way around. And the substitutions I make are substitutions that we made in the previous section as well. So x will be r cos theta and y will be r sine theta. And that way, we're able to convert from and to polar coordinates. Sometimes we're really not sure what a graph will look like when it's given to us in polar coordinates. And one of these examples is a shape called a cardioid. So we'll write that. A cardioid will have some type of equation like r equals some number, let's make it, in this case, 2, and then plus or minus sine or cos theta. Let's make it plus cos theta. Now the way we draw something like this can be helped by first of all drawing what this might look like with Cartesian coordinates, but r and theta. So by that I mean we might draw a set of axes like this and draw 2 plus cos theta, where this is r and this is theta, and this will look something like a line of 2 and cos theta is going to be like that. And then what we'll do when we sketch the actual cardioid, what we'll do is we'll consider that when r is this value, this will be 3, my angle theta is 0. So there'll be a point at 3 and 0 here. Then as my theta increases, remember here for argument's sake, I'm going to have the point pi over 2 for theta and 2. So therefore, when r is 2, when theta is pi on 2, the distance will be 2. We can keep going. When theta is pi, my distance will be 1. When theta is 3 pi on 2, my distance will be 2. What I actually end up with is a shape that looks a little bit like this. And that generally forms the shape that might be a bit like a heart. And therefore, it gets its name cardioid. So, in summary, when we're graphing with polar coordinates, circles that go centered at the origin, or straight lines that are centered at the origin, are really easy to manage with polar coordinates. Straight lines that aren't centered in the origin do require some sort of manipulation, but polar coordinates are really handy when it comes to simplifying the equation of some quite complex shapes, and one of these shapes is a cardioid. If you found this or any of my other videos helpful, please subscribe to my channel or like the video. Thanks.